I work at Twitter, and this is Well-Dressed Scala with Pants. Pants is definitely the project name that keeps on giving. So I was realizing earlier that we've never printed a pants shirt, and that would be very confusing, so maybe we shouldn't. But there are the pants stickers that I mentioned. I have more. Let's talk about what pants is. So first of all, let's talk about what the goal of a build tool is, and particularly Pants' goal. Let's talk about monorepos again. We'll get to that. And then I'll give an example of how to get started with Pants, since I will have already convinced you in the first 20% of the talk that you should. And then why Pants, a little bit inverted, because it has Scala-relevant features, various other strengths, and a very healthy community. And then I'll talk about some of the upcoming work with Pants that some of you might be able to participate in. So again, if you have questions during this, raise your hand, and I'll definitely get to them. So what is the goal? The goal is to make it easy to build and share any size project. So it's not just to build projects, but to allow for sharing of the code. You do write binaries, you do write servers, but what we want at Twitter and probably at a lot of other places is to share our code. So we want to write libraries. We want every person who writes a server or who writes an executable to also write libraries. There's definitely reusable code in there. Make it trivial to share. Also, the size bit, right? It can be, if you've made it very, very easy to share, things are going to grow because people are going to share, and you're going to have this multiplicative effect. And so our goal, our solution to this goal is monorepos. So why a monorepo? We want to make it ridiculously, dangerously even, easy to share code. We'll talk about that. So all of these are kind of things about dependencies. You want to introduce a dependency. That's how you share code. You don't want to have dependency diamonds when you're making changes to code, when you're sharing code. You want to be able to, if you need to depend on something that is some small portion of some other library, you want to make it really easy to mutate your graph, right? You want to make splits atomic so that I can split some library, update everyone who calls it immediately in one go. I don't have to make, for a core library, I'm not going to change that and then have to change 200 other repos. Doesn't matter how much automation you have, that's going to be a pain in the butt. It's not what they're designed for. So putting that all in one repo makes this a very easy process. We'll get to that. So top to bottom continuous integration testing. It's just one repo. How do you test one repo? Well, you run the test through in that repo, which means you get it all the way when some core library changes all the way to the top without writing continuous integration infrastructure other than run all the tests. Obviously, there is some small amount of infrastructure involved when you have many millions of tests. But we can get to that. Linear change history. So it's one Git repo. It's one Mercurial repo. You have a linear change history. You can Git bisect to figure out exactly what broke you. Very commonly, you bump from some major version to some other major version. At least 3 things break. You have really no idea how to figure out what that is without diving into that code. As a consumer, instead, in a monorepo, you just bisect. You just bisect to exactly the commit in that other library that introduced your problem. So downside of that, of course, is that sometimes if your tests suck, it ends up being the service that has to do that bisect. And additionally, there are no binary incompatibilities except at the boundary. We are down to 2 lines in our repo of 20 million lines of code to switch from one Scala version to another. Swap those 2, run a sandbox, see whether everything breaks. It will. But and really, that's just an argument for source distributions. We have all the source. That's great. We call the repo the source repo with a capital S. And it's confusing as hell. But that's what's in there. Source distributions are kind of great, and it might be a direction that Scala heads in. OK, but yeah, it's dangerously easy now to add dependencies. I don't have to worry about diamonds. I don't have to actually choose a version of a thing. Just bam, add it. So you have to then manage your dependencies. we have dependency analysis tools in Pants, and regardless of the monorepo, and probably regardless of the system, you want to be able to analyze your dependencies. Pants has this dep usage goal, which implicitly is going to run dep usage for our JVM targets. We also have underused dep warnings, but both of these are about determining whether you're actually using something at all, or if you are using it at all, whether you're using it to a degree that justifies spending X amount more time building it. Right? We have very good build caching, but if you don't need a thing, you probably shouldn't build it. So those are existing. Rewrite tools, I think, are a growing and very, very important component of how we do software development. In particular, we have massive amounts of source. Everything's in the open. We can see how much work is involved in making some library change. You don't want that to scare the person from scare them away from making the library change. You want them to have some automated way to fix things. And I see Oscar has a question.
I was going to ask, could you say something about how the underused Deps, how is that done? Is that
Sure.
in cooperation with Scala Compiler, or
Yeah.
how do you know if, when
Yep.
you say to justify, I wonder if you could say a little bit more about what you mean by that?
Sure.
Okay.
Yeah, absolutely. So the question was about how we accomplish the underused dep warning and what it means to kind of justify a dep. So we use Zinc, and Zinc keeps track of sub-file level dependencies, class level dependencies, and actually symbol level dependencies. And together you can figure out which classes are using which other classes. And so we dump that out in either a JSON format or in a flat format that basically just says, within this context that you just built, you use this target at 0%. Therefore, even if it's transitively something way down in your dep graph, you don't need it. Nobody needs it. You can delete that dep anywhere within your graph. And using the output of that tool, you can also rewrite your graph to say, delete all unused dependencies, which Twitter did recently, and we dropped 30% of our dep graph away. So that was wonderful. What does it mean for something to be underused? Excuse me. So one metric of a healthy dep is kind of what is the velocity of the code. Too high can actually be bad for you. That's an expensive dep relative to something that's really stable. If you're using just 1% of something, particularly if it's a source dep, you're imposing some build cost. And you're also imposing like startup time costs maybe, depending on how the indexing ends up working there. So yeah, the decision is an interesting one. From what we can tell, and I think this is kind of going a little bit off topic, but from what we can tell, people will continue to add deps as long as their system, as they're like comfortable with their current performance. And as soon as they get uncomfortable with their performance, they'll drop them. So really that means you need to be always pushing performance because you want people to share code. So the last one here is build level refactoring tools. This is a place where we're a little bit behind. I'll get into how Pants declares targets, modules. But in particular, if you want to make it super easy to share code, you want to make it super easy to refactor code to make it easier to share, like lower the surface area of some library. And it should be a one-liner to split some module, some target. Did you start to have your hand up, or? Oh, I'm sorry. Yes. Raise your hand if you've heard of monorepos or know. Okay. And then who knows, is fairly confident they know what a monorepo is? Okay. Oh, shoot. Sorry. Well, I said again because this is kind of my thing, and so I assumed. Apologies. So a monorepo is essentially any time you have multiple modules in one repo. And so a lot of projects are monorepos at some level. It's also sort of used to, it's primarily used to describe it when it like really starts to go overboard and you have more than 10, but really if you have 2, you begin to have a monorepo.
Yeah, I just meant that if you like the whole your code base will be in the same repo, it will be problematic to get some code reviewed and merged without conflicts, and you'll like just like rebasing them all the time.
yeah, so the question was, how do you not have merge conflicts? Unless you have hundreds of people working within the same directories or on the same Deps, merge conflicts are very rare, actually. I mean, it's kind of remarkable. Our very largest projects in the Twitter monorepo touch, so our very largest services touch 1.5% of the graph at all, right? And so then but also they tend to write code within their own module. So things will come in below them in their transitive Dep graph, but that doesn't actually cause them to fail to merge. The tests have to be rerun before you merge that, but conflicts are surprisingly rare. So, yeah. Does anyone have any more questions about monorepos? Because now I'm realizing I might not have.
Do you run into Git performance issues?
Absolutely. The question was, do you run into version control performance issues? And yes, absolutely. 3 or 4 years ago, when Twitter moved to a monorepo, we were using Git. We patched Git quite a bit to make it performant enough for the code. And it's really not too large of a repo. It ended up, after pruning, ended up being something like 10 gigabytes, the entire history of Twitter's code. Obviously, other people have larger ones. But since then, in the last 4 years, a lot of the patches that we created have either been upstreamed or had variants upstreamed, and also the Git project itself has matured a huge amount, to the point where one of the things we have is a log-based fetch, because git fetch in particular does this, here are all my refs, which refs do you have? And if that's something like 40,000 refs, then you end up touching disk at least 40,000 times. But a log-based thing just pushes out all changes as quickly as possible. But yeah, there have been improvements to fetch upstream, and we actually have to see whether it's now not even, like out of the box, it would just work. So I think there are a lot of companies pushing on SCM like this. And so it's not, unless you are one of those, you're probably not going to hit the issues. They're existence proofs. So, yeah.
How do you open source a project from your monorepo?
Yeah, good question. So how do you open source a project from a monorepo? Git subtree is generally sufficient. You can also use submodules. Pants in particular, though, is just gaining support for merging multiple repos at a native level, such that you could have a submodule and have it be using an independent pants build. And I'll kind of get into what that looks like. But as it stands, a lot of those projects have their own separate build. Like they have an SPT build. That's unfortunate. We want to actually be able to fix that. And so either that support pants native support for submodules, or there are a bunch of different tools. Facebook and Google both have one, and then I'm sure there are others related to this problem, where you essentially whitelist a series of things that you need. And so in particular, within our repo, you could whitelist essentially the transitive graph of that project somewhere. So all of the source steps are in that same repo. And then whatever config you need out of this much larger repo. So, okay, let's move on. So example, minimum viable pants. Now you're all convinced. Let's say that you wanted to install pants. Pants is designed for monorepos. Good. We have one of these kind of scary curl contraptions to get you started, but it's just basically putting this in a script that you will then execute. Put this at the root of your repo. And all of this is explained at that link. None of this is technically necessary, but I wanted to show an example. You can actually start pants with an empty pants ini. This is, again, at the root of the repo. It's useful to pin the version that you're going to get. 1.2.0 is the latest stable release. If you don't pin that, you'll just go whatever the latest is, and it will float. And so you might not want floating. You want to pin that down. And then this is just an example of another argument section with a fancy new feature enabled that I'll show you. Make a directory to put some code in. put some code in that directory, create a build file. Now, this is using a default target name, default sources, and it's a library with no dependencies, right? So it's just this one-liner of Scala library, right? It's a default target. That means it actually is named example, source Scala com example. The library's name is example because it shares the directory's name. And the default sources for Scala libraries are star.scala, essentially. Then run it. So echo println to our REPL. Pants has that script that you downloaded and set executable. It sits in the root of your repo. There's no need to install Pants on a user's machine. It bootstraps itself. The REPL here is going to take from standard in, voila, and we execute. When this is actually running, the first time it's going to take something like a minute because it will actually download everything it needs to compile this and then execute it, which includes zinc, Ivy, which it will bootstrap, et cetera. So first time you run will take a little bit longer. Second time, it should be on the order of 500 milliseconds. OK, so that's it. The reason I walk through this example is that Pants has gotten orders of magnitude easier to use in the last year. Pants hit 1.0 in May, and our goal for 1.0 was to essentially get to zero config. As I said, even though Pants INI was not strictly necessary, but you probably do want to pin your version and also pin your Scala version. You saw here that we got 2.11.8, just because that's the default that we have configured for the 2.11 branch. There's a one-liner to go from 2.11 to 2.12 in those options, right? So that's it. Like re-examining some of the stuff we did, Pants has lots and lots and lots of options. We put some of those in the Pants INI. Pants options pipe to grep for that option we had. OK, true. This is set to true. Came from config in Pants INI. These implicit sources is what allowed us to not specify what sources that target owned. And I haven't really even explained what a target is. Apologies. This is a target. You put it in a build file. It owns some sources. Other things can depend on it. I didn't show any examples of dependencies, but a Scala library target, if it depended on some other target, would literally just say dependencies equals source Scala com foo, right? That I depend on that library, that target.
Hopefully this isn't too much inside baseball, but is that the kind of current best practice to because I know the 111 style that people like.
Yeah.
You just do like don't list sources anymore. We're just going to get all of them. Don't give it the targeted name anymore. It's just going to be the thing.
Yeah. Yeah. So the question was about, is this the recommended style? Yes, this is definitely the recommended style. The reason this became the recommended style is because of this property that you helpfully mentioned, which is this 111 property. It's actually super helpful to explain how we like things to go down. We like a single directory to equal a single library or binary to equal a single package in the language, right? So ideally, source Scala com example contains only software for the com example package, right? I know where that package lives throughout the entire repo, so I have this normalized namespace. And introducing default target names and default sources the idea is to push people toward these best practices by making them very, very easy. So Twitter stripped out all of the names and as many of the source definitions as we could in our repo recently, which was awesome. Any other questions about the examples? OK, well, yeah, example. Options. There are a lot of options. We use options for a lot of things. Now, that doesn't give you very much information about what this is actually doing, right? So let's get more. CLI args, the Pants INI file, and environment variables are all normalized into the same option system. So Pants help advanced for target arguments, which is the kind of namespace this option was in. Target arguments, implicit sources, right? It's the namespace concatenated with the actual option name. Defaults to true. If true, Pants will infer the value of the source's argument. So it is optional to allow implicit sources, which is what allowed me to have that one-liner Scala library where The default is just to glob everything, right? You can turn that off. We don't roll things out, breaking changes without having some option associated with them, right? So we move very quickly. We have releases every week, and then we have stable releases every 3 months. And part of that means making sure that we don't break things. So yeah. But yeah, this help, this is a fairly, this would have been something like 200 lines of help. The exception to this unified set of options and CLI args and environment variables is that when you define a target, you give it arguments. So there's this differentiation between things that you want users in your repo to be able to configure locally versus conventions that you set globally within the repo. And there are a few different ways to look at that, and we can get into it. But as a very simple example, like a resources target, which defines a set of resources that some other target might want to depend on, has a few different options here. And this whole page is significantly longer with all of those expanded. So finding page works. So yeah, why else pants? Scala relevant features. We have all the things you'd expect, right? From a tool that builds Scala. We have integration with Intellij. We have daemonized warm compilers. And we have multi-JVM platform builds in the sense that you can have a Java 8 targeted Java library depending on a Java 7 targeted library. That's totally legal, and you'll get the right JVMs for each of those. We have native support for Maven and Ivy style publishing. So Pants publishes itself to Ivy Central, or to Maven Central, excuse me, along with a lot of other libraries. Scala doc, Scala format was added recently. Fumpt. I can't call it Fumpt, sorry. Scala style, check style, find bugs, scope dependencies, which are similar to Maven's scope dependencies, except rather than being on a dependency edge, you define it on the target. The idea being that in a monorepo, you don't want to just change your own code. You really do want to try. You want to bias toward changing the code you depend on, right? Because you're going to have multiple people depending on any particular library, and fixing it in the right places is beneficial, et cetera. What we also have, though, is we have very tight integration with Zinc. Zinc has a weird history because Zinc used to be just a daemonized wrapper for SPT, is essentially how you could think about it. But that project died, and it was rebranded. The incremental compiler of SPT is now just called Zinc. So SPT uses Zinc, is the new way to think about it, right? So we also use Zinc via a daemonized wrapper. So we have very tight Zinc integration for Java and Scala. It's important to have it for both Java and Scala, because if you have a path from Scala to Java back to Scala, and the Scala library behind the Java library changes, you don't want to have to recompile all of the Java. Happens a lot. And so you need analysis. And this analysis is sub-file, again, as Oscar pointed out, sub-file and at the class level information about which classes depend on which classes and which classes depend on which symbols, basically. Additionally, we have an incremental aware distributed build cache. The incremental aware bit is very important, essentially because you really can't trust Zinc and SPT. If you use SPT, you know periodically you have to clean all. We've inherited some of that, right? I'm not gonna lie. We have inherited some of that due to our usage of Zinc, but we are aware of which compiles are incremental or not. We never trust the incremental compiles. So only trustworthy compiles go in. Now with the optimizer where it is, according to everyone, with regard to 2.12, it's really seeming like this is a great time to use this incremental awareness to conditionally enable the optimizer wherever you can, right? You can't use the optimizer with the default SPT incremental compilation, and so we will be very careful to differentiate those artifacts in our cache. And as I said, we have the dependency analysis tools. This will spit out either like one line per transitive dep or an actual graph that you can then analyze. Also, yeah. So we're also CI and user-friendly. you can test all the targets that have changed in your branch, for example, because we are actually looking at the git diff, and we can tell you which targets have changed. So pants -- changed parent, or you could do pants help changed, and it will give you information about what options are available there. But pants changed parent master test is basically going to choose the roots for your test command, choose which targets to test based on what has changed between your branch and master, or master and your branch. You can also just report which files are transitively used by a target. All of this is very important for caching, and getting this right is critical to actually caching the right things and not having the wrong cache keys. And so exposing that out. This is frequently used. Again, I said, what do you do continuous integration testing wise in a monorepo? Well, most systems, because there is not a standardized distributed test runner, are going to do something like figure out what targets have changed, partition them some way, use whatever system you happen to have available. I'll talk about how we want to improve that a little bit later. So why Pants? Again, community. So we are an inclusive nonprofit organization, Pants Build, and it's independent of any participating company. So I've got this Twitter shirt on, we're at Twitter, but this is a completely independent org. All development has happened in public on GitHub for the past 4 years, and released 1.0 in May. So again, we do unstable releases weekly, stable releases every 3 months, and the big difference from the last time I talked about Pants is that we are absolutely ready for wider usage now. This 1.0 milestone was not an insignificant milestone in terms of what our focus was. And as I showed, it's down to very, very low configuration for the common case. Also, the stable releases began at 1.0, so we have this good migration path for people. There's a 6-month deprecation cycle, so 2 stable releases before we'll remove something. You'll get warnings on options. It's kind of amazing. So, strengths. So as I showed, our goal is to kind of try and minimize boilerplate. We want to minimize the boilerplate required to define a library. We're down to 1 line. That's pretty good for this like default case that we want to encourage, right? We want to have a directory that represents a particular package and has at most 1 line, hopefully, plus dependencies to be defined. By default, Pants targets are not publishable off to Ivy and Maven. You have to add some additional config there. At least within Twitter, that's the right decision. Outside of Twitter, it may not be. But it's easy enough to add a macro if all of your libraries within your repo should be publishable under some org. You can just make that a required argument via using a Pants macro. So by default, if you try to publish something, it'll say this hasn't been declared publishable. And the reason again is that Twitter, despite having a fair number of open source projects, has a relatively low fraction of the graph that is open source. So we could do better there. But we don't want to introduce magic. Almost all of these behaviors are explicitly driven by options. So consistency. Again, we want to make it easy to enforce repo-wide defaults. Local overrides in some systems are kind of the norm. And so when you're looking at some repo, you want to figure out what is the right way to do a thing in this repo. It depends which directory you go into. You'll find like entirely different things going on in subdirectories. Consistency is very important in growing a code base. As an example, JVM platforms. You can't just in some build file define a brand new platform. We need to know which ones are supported by the repo. It's not significantly harder. So this option, right? This is in the option syntax. That will also go in pants-ini. That'll also go in environment variables. But generally, you pop this in pants-ini to say this repo supports this platform. And then locally, you have this relatively simple way to specify, well, I want to use the default, or I want to override to a particular other platform. As I said, incremental compilation. even when zinc is not in play, if a target has already been built, we don't rebuild it. And we support this distributed build cache. And then additionally zinc. Another strength we have relative to other, in fact, even to other monorepo build tools, is that we kind of support huge, real Dep Graphs. And I'll get to that. So you have tens of thousands of source targets. You have thousands of third-party Deps. And a third-party Dep is any Dep that's coming in as binary, right? It's open source code. It's closed source, but it's a big blob of something. And so we support less than perfect third-party dependencies. A company like Google, which is where this idea was really born, probably, at least Pants's model was born there, has never probably had enough third-party dependencies to need to have a messy Dep graph where they support multiple libraries for very long. But the real world of open source libraries generally means that within some repo, you're immediately going to have two versions of Elasticsearch. You're going to have two versions of Hadoop. Spark hasn't, I don't think Spark has screwed us yet there, but yeah, outside of the world of monorepos, big version bumps screw everyone, right? So you end up with these divergent.
Spark 2. There's some
Is it
stuff.
similar? Yeah, okay. Yeah, you end up with these big version bumps that essentially bifurcate your monorepo a little bit. I can't depend on you if you need Hadoop 2 and I need Hadoop 1, right? And so we kind of recognize that, we support that as best we can. So extensibility, yeah, we have support for a few different languages. We'd love more. There is kind of fledgling Android support. There is no iOS support, although somebody was mentioning that recently. But these are all things that we absolutely want. Twitter in particular is going to be focusing on mobile support in Pants over the next year, along with a few other things. But almost all deployments of Pants have some custom plugins and macros, because it's easy to do that in your repo without forking Pants. You can extend almost anything within Pants without forking it, which is another benefit. And I didn't really mention, but we have another part of 1.0 was that almost all APIs are marked either public for usage in plugins or not. And any public for use in a plugin API has that same deprecation cycle. So let's talk about upcoming work. We have recently refactored the internals of Pants post 1.0 in a completely transparent to users fashion to implement a new native engine. So the effect of this is that no op, i.e. I didn't change anything, I'm just rerunning. And incremental, I changed just a small amount of it, and I don't want to rebuild everything. Executions get significantly faster. We already use daemons. Zinc was always a daemon, so Zinc is always warm. JVMs kind of need to be warm. But since the rest of Pants is in Python, which I might not have mentioned yet, it is now a Python and Rust system. And the daemon is primarily Rust. It's still optional. It will become the default as soon as we shake out the last few bugs. But I think the fundamentals are very good, so we're excited about that. It will likely not justify 2.0. We're going to save 2.0 for the next UX changes we make. So some major version between now and then, we'll turn this on by default. Strict Deps. So this is a thing that begins to become an issue when you have Dep Graphs involving 2,000 modules, right? When you have 2,000 modules in one server, right? 2,000 libraries, targets, whatever you want to call them. Invalidating those upstream targets every time one library downstream changes can get very expensive. The compiler doesn't actually use the entire transitive, i.e. recursive, i.e. Dep graph of some dependency. Unfortunately, with Scala, it's not entirely clear which it uses, and so we have work to do there. Java has had good rules up until 8, where if you imported something, it needs to be on your class path. If you didn't, it almost certainly does not need to be on your class path. And that allows for things like, well, I have this 2,000 module graph, but this target that I'm about to compile only actually at compile time is going to need 10 or 20 of those, right? That's great for cache keys. The library that I don't directly depend on has changed. I don't care. I don't even need to wake up to recompile this. So a compile will walk only as far as it needs to and then stop. So we'll be turning that on for Java. It's already implemented. And we hope to work with the Scala community to do this. We're very happy to have Eugene joining us to help accomplish that. It will certainly benefit other build tools, hopefully. So, and additionally, we want to work on supporting remoting, which is kind of transparently executing builds remotely. It is at least partially blocked by strict Deps, the thing on the previous slide, because shipping 2,000 things to some remote node is massively more expensive than shipping just 10 or 20, the strict Deps. So that's an important change that we're going to try to roll out before we focus too much on remoting. And yeah. Right, so the upcoming Twitter open source project, you'll hear more about that fairly soon. And I don't think I'm giving too much away to say it's called Scoot, and look out for it. Additionally, we're interested in attempting to infer Deps. This is probably the longest term of all of those. When you have consistency throughout your repo, and you have these namespaces where this particular package could only live in one directory in the entire repo, if I import something from that package, I know where it lives in the repo. And if it doesn't live there, it lives under third party. So you have these two namespaces of binary Deps that are coming in from the outside world and sources that live in the repo. So if I import it, why do I need to repeat that in my build configuration? So this consistency allows us to hopefully, and consistency and normalization, I say, allows us to hopefully infer that based on imports. So stretch goal, but we're very excited about that. We don't really believe in the kind of masochistic, well, I should have to repeat this. I should have to repeat myself to like bang it in my head that I have a Dep. We have tools for that. Okay, that's everything. Does anyone have any questions?
So zero config looks pretty cool, but what about stuff that people typically do in builds, like integrating with, say, front-end Webpack builds, or starting servers, or like a lot of other stuff that you can't just infer automatically?
Yeah. So the question was about what do you do when you want to start servers or have essentially different deployment stories? Is that? Yeah, so Pants supports all sorts of different plugins. And what we have built in is not super extensive, but we have things like RPM build and Docker plugins actually currently out for review. In terms of starting servers, I think one thing, you could certainly do it in a plugin, but one thing is that will interfere ever so slightly with the idea of remoting. You want your tests to be sandboxed. So our goal has been to sandbox tests to make them as reproducible as possible. And so it's ever so slightly in conflict, but totally possible to do in a plugin.
Sorry, so like oftentimes build file will have like, so I want to compile, I want to run tests, but I might also want to start my server just locally.
Yeah.
Do you just pull that out of the build definition and make it a separate script? Or
Absolutely, yes. So none of that goes in the build definition. Yeah, I'm sorry. So the question is, if you wanted to start a server, would you put that in the build definition? So Pants has this slightly alternative model, not particularly though. It's kind of similar to the Maven model in that you have goals, and I have some minimum amount of configuration on the target, but then I might have a goal I would have a command line goal that I want to accomplish. And if the goal is to start a server, the plugin wakes up there. If it needs any additional configuration on the target, you can specify it on the target. Or you would have options on the goal that are kind of global options for the repo. Here are the default port ranges that we grab. Any other questions? Okay.
So you talked about source Deps. Like it sort of guess what that is and how it works, but I assume there's no version. It's just like you depend on the
Yes.
source within the same.
Yes.
Like the latest version.
Yeah.
That's kinda how it works.
Yeah. So the question was about source steps, and this is fundamental to a monorepo. So I apologize for not getting that. But yes, so nothing is versioned in the repo. You don't have an organ and name, so there is no way to even say that something had a version. There's nothing to attach the version to. In theory, you could version a target, but so internally, the best way to do this is an example. Internally, our CSL team ships some change, or they ship a bug. What they say is, oh, a bug was in master for this SHA range, right? Because we know it was in for this SHA range, we know these services are affected by it, because these services were deployed at that SHA. And so SHAs kind of end up being your version, but you never, ever, ever think about them except when you're dealing with third party. So third party is where all of the external binary version Deps live, and then otherwise you have source steps. And a source step it's as easy to add a source step as adding like a single line in the build file. When you do that, it's very, 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 very unlikely for you to have a Dep conflict, because third party is this massively smaller, well-maintained set of versions that is self-consistent, mostly, with the exception of things like Hadoop 1 and Hadoop 2. So thank you, everyone. There'll be stickers over there, and I'll be around.